Good afternoon. So today we're going to be continuing on with the topic 16. We will go to where it says student activity sheet 2 at the top, page 1 of 8. So as I put notes on here, you should be copying them onto your paper as well, and then using that to answer some questions, and then we'll go over some. As I put notes on the board, if you need to pause, definitely pause, and then you can resume it once you finish those notes and go on to the next thing. I'm going to be going back and forth between Agilemind and our document. You just need to be on the document itself, as well as this video. There is one additional app that we're going to be using, but I'll talk about that once we open it. As the Bradleys have discovered, building costs are generally determined by multiplying the square footage by a set amount, like $150 per square foot. The price covers the cost of pouring the slab, running the utilities, framing, putting up walls, painting, and roofing that area. To be sure that the house fits into Bradley's budget and lot size, the architects initially increase or decrease individual rule dimensions by X feet, as shown in the image that we have in our document for question number 1. After the modified house plan has been designed, the Bradleys can determine this X value so that the cost for the total square footage fits the budget. So what does X represent in the Bradleys house plan? X equals the length added to the original dimensions. Notice that the dimensions on the modified house plan are polynomial expressions. Recall that polynomial is a sum of expressions that are numbers, variables, or products of numbers and variables with non-negative integral exponents. These expressions are called terms. Play the animation to learn about other vocabulary related to polynomials. So here there are 14 polynomial expressions shown on this house plan. These ones that are highlighted on my screen are monomials because there's a single term. Here, these are binomials, and notice that this contains 2 terms, and those terms are separated by addition. In general, terms can be separated by either addition or subtraction. At the top, we see a polynomial with 2 terms, like x squared minus 6x, or 5xy minus 7 is called a binomial. There are 2 terms, and in this case, they were separated by subtraction. Let's go back into our document and first define what a term is. So terms are expressions in a polynomial that are numbers variables or products of numbers and variables separated by addition. or subtraction. And we just looked at an example of a monomial is a polynomial with one term. So in the definition, we'll put a polynomial with one term. And here we have an example. So then the next type of polynomial has two terms. And what do we call a vehicle that has two wheels that you pedal? A bicycle. So this is a binomial. A polynomial with two terms. And then what do you call a vehicle that you pedal that has three wheels? A tricycle. So this is a trinomial. Is a polynomial with three terms. So when I'm writing this out, I know I need to have either two additions or two subtractions to separate those three terms from each other. So here I can put x squared plus 5y plus 6. I know that this is a trinomial because there's 1, 2, 3 terms, and those three terms are separated by addition. Okay, so what is the degree of a monomial? The degree of a monomial is the sum of all the exponents associated with each variable in the monomial. So let's just write that definition down, and then we'll go over an example for question number 5. So the degree of a monomial is the sum of all the exponents for each variable. So for 3x squared y to the power of 4, x has an exponent of 2, y has an exponent of 4, so we add those two together. So the degree is 6. So I'm going to do 2 plus 4, and then I'll write out the degree is 6. And this is when you're just looking at a single term or a monomial. So for a polynomial, the degree of a polynomial is the same as the degree of the highest degree monomial in the polynomial. So the same as the degree of the highest degree monomial. So for our trinomial example, the first one had a degree of 2. Second one, this y has a degree of 1. And 6 doesn't have a variable. So if it doesn't have a variable, it has a degree of 0. So out of 2, 1, and 0, which of these is the highest? Yes, 2 is the highest. So this would be a second degree trinomial. So the two ways that you can classify a polynomial are first by the degree and second by the number of terms. If you have something that is more than 3 terms, then you can just call it a polynomial. If it has 4 or more terms, it's a polynomial. Okay, try questions 7 and 8 on your own, and then we're going to go over those. So you can pause the video now and then resume it once you finish those on your own to review if you got your answers correct. Okay, so for question number 7, I'll look at the degree of each of these. So what is the degree of the exponent for 7x to the power of 4? Yes, it's a 4. The degree of 5 to the power of x, this doesn't have an exponent, so it means that it has an exponent of 1. It has a degree of 0 if it doesn't have a variable like we have for the -3. This has no variable, so it has a degree of 0. So out of 4, 1, and 0, which of those is the highest? 4. So 4th degree, and this was 1, 2, 3 terms, so trinomial. What is the constant term? So the constant term has no variable attached to it. So in this case, -3. And then the leading coefficient. So coefficient means a number that's in front of a variable. So in this case, the leading coefficient of the highest degree is 7x to the power of 4. So I just take that 7 out and can write that 7 is the leading coefficient. And the reason why is 7x to the power of 4 is the highest degree. And we're taking the number that's in front of that. When writing a polynomial, the standard way is to have the highest degree first and then the lowest degrees after that. Okay, for number 8, you were matching the special name and then the degree. So the special name is just counting the number of terms. So for this first one, there's 2 terms, so that's a binomial. And then for the degree, 3x squared has a degree of 2. Minus 75 has a degree of 0. So out of 2 and 0, the highest degree is 2. So when I name this, it would be a 2nd degree binomial. Here we have 3 terms, so that makes it a trinomial. And the degrees are 3, 2, and 1. The highest out of that is 3, so this has a degree of 3. How many terms do we have for this next one? Yes, 1 term, so that is a monomial. And because this is a single term, I add all of the exponents together in this. So I'm going to write in that y has a degree of 1 and z has a degree of 1. So then 2 plus 1 gets us a degree of 4. This next one has 3 terms, a trinomial. The first term, 6a to the power of 2, has a degree of 2. 2ab, a has a degree of 1, b has a degree of 1. Together they have a degree of 2. And then 2b to the power of 2 has a degree of 2. All of these have a degree of 2. So the highest out of 2, 2, or 2 is 2. The last one is a binomial. And this binomial has a degree of 1 and 0. The highest number out of that is 1. Okay, use the distributive property to simplify 20 plus 3 times 10 plus 7. So when we're doing distribution and I have 2 terms, I need to do first distribution on top and then distribution underneath. So first I'll do 20 times 10. And I'll put these in parentheses so I know that I'm first doing the multiplication and then doing addition at the end. And then I do 20 times 7. Then I'll distribute on the bottom. 3 times 10. And then 3 times 7. And then I'll solve each of these 4 and then add them together. 20 times 10 is 200, plus when doing 20 times 7, I first do 2 times 7 is 14, and because it was 20 instead of 2, it's 140. 3 times 10 is 30, and 3 times 7 is 21. So then we add all 4 of these together, and I get 391. And this is looking at the dimensions of something, so I'll put the units as being feet squared. So one way of multiplying a binomial times a binomial is by doing this double distribution. Distribution on top, then distribution on the bottom. So I'm multiplying the first term by both of the second terms, and multiplying the second term by both of the terms in the second binomial. There are other methods for solving this. One of those is to use the box method. So for question number 10, start by just drawing a box, and we're going to split that into 4 quadrants. And on top, I'm going to put the first binomial, so 20 plus 3, and on the left side, I'm going to put 10 plus 7. And then I'm going to multiply those by each other to fill in the inside of the box. 10 times 20, 200, 10 times 3, 30, 20 times 7, 140, and 7 times 3, 21. And then we add all of these together, 200 plus 30 plus 140 plus 21 equals 391 feet squared. So all of the multiplications that we did here, as well as with the distributive property, were exactly the same products. And in the end, when we're adding those together, we still get the same thing. When we are doing this with variables, a lot of times at the end, there will be like terms that will combine, and those will usually be diagonal to each other. So we'll see that when we solve this next one, which does have variables. And first, we're going to solve it with the double distribution. Then we'll solve it with the box method. Okay, so use the distributive property to simplify 3x minus 2 times 2x plus 2. So 3x times 2x. 3x times 2. Then negative 2 times 2x. And then negative 2 times 2. And notice that in between all of these, I use just addition. And if the value had a minus in front of it, I just made that value negative. Okay, when we're doing multiplication, remember that you are also multiplying the variables by each other. So 3 times 2 is 6. And then x times x is x to the power of 2. 3x times 2 is 6x. Negative 2 times 2x is negative 4x. So I still have the plus the negative 4x. And then negative 2 times 2 is negative 4. And then I'm going to look to underline our like terms, which are +6 and then -4x. Both of these are like terms because they both have an x attached to the power of 1. So I can combine those two together to be equal to 2x. So 6x squared plus 2x minus 4. So now when we scroll down, we're going to do the same thing that we did for question number 10, but this time we're going to have a variable with it. So again, start with drawing your box. And we'll split it into fourths. And on top, this time I'm going to put 3x. And the second term is a -2, so it'll be a -2 here. And then on the left side, 2x and +2. And then this is similar to an area model that you guys worked on in middle school, where you multiply the length times the width. So for this first box, it's 3x times 2x, which equals 6x squared. Then we have 3x times 2, which equals 6x. Then I have -2 times 2x, which is -4x. And then I have -2 times 2, which is -4. Our last step is still to combine like terms, but this time our like terms are the ones that are diagonal to each other, because both of these have an x. Everything else stayed the same except for those like terms that I combined. So it starts with 6x squared, and then 6x and -4x is 2x. And then we have a -4 at the end. Okay, when multiplying or doing operations with polynomials, we can use algebra tiles, like when we were doing addition yesterday. So in your browser, you can go to Polypad. If you just Google Polypad, it should come up as the first option. Polypad virtual manipulators, click that at the top. And it'll automatically put you into geometry, but I want to select the green algebra and then select algebra tiles. So here we're doing the same thing where we're setting up pretty much an area model, but in this case, instead of using numbers, we're going to use tiles. So X is on top. And then I have another X next to it. On the left side, I had three X's. And let me look back at problem. So this next problem is 3x minus 2 and 2x plus 2. So on top, I'm going to have 2 x's and 2 positive ones. So positive 1 there. Duplicated to have 2 positive ones on the top. And then on the side, I need two negative ones because it's 3x. Need one more x here. So duplicate that again. Where did everything go? Okay, let's start over. Okay, 2x on top. 3x is on the side. And then 2 1s on the top. Just double checking. And then 2 1s on the side, but they're negative. And then I'm just filling it in with what fits inside of this remaining area. So I know here we're going to be able to fit 3 of the big blue x squareds. So this represents 6x squareds. And then on the left side, 1 times x is 1x. So I have 2 times 3x's, which will equal 6x's. So I need 6x's that fit right here. So then on the bottom, I have the x on top times a -1. X times -1 is negative x. And I can fit 1, 2, 3, 4 of them here. And then on the bottom right, I have 1 times -1, which equals -4. So -1, 2. And then need 2 more. -3, -4. So then my answer is what is left inside. So I can ignore everything that's on the outside here. So I can take those away. And then I'm just counting the number of x squareds, the number of x's, and the number of 1s. So we have 6x squareds. And then here I have 4 negative x's and 4 positive x's. 4 negative x's and 4 positive x's cancel out to be 0. So I'm left with 2 x's and 4 negative 1s. So in here, we'll write 6x squared plus 2x minus 4. The 2 x's were positive, that's why it's plus 2x, and the 4 negative 1s were all negative, so that's why it's -4. Okay, we'll do one more of these together using the Algebra tiles. So let's switch back to Polypad, and I'll just refresh the screen to just clear everything off. Okay, so I'm looking at the next question. It says to use Algebra tiles for 2x minus 3 times x plus 1. X plus 1 is on the top. And then I'll rotate this. Negate it, duplicate that. Because it's 2x. So these need to be positive. Minus 3 times x plus 1. So x plus 1 is on the top. 2 x's and 3 negative 1s are on the left side. So then we're filling in the inside with what fits. So here I can fit 1x squared, 2x squared, and then on the right side, I have 1 times x, which is just x. And I can fit one more of those right here. And then what is x times negative 1? It's a negative times a positive, so it's equal to a negative. So that's negative x. And I have 3 of those. And then in the bottom right, I have 1 times negative 1, which is equal to negative 1. And I can fit 1, 2, 3 of them. My answer is this part that's inside, and I look at canceling out any 0 pairs. By a 0 pair, I mean a positive and a negative of the same exact term. So I have 2x squared, so nothing cancels out there. Then I have 3 negative x's and 2 positive x's. I can group up. 2x and minus 2x cancels out to be 0. So I can clear these off, and that leaves me with 1 negative x. And then I have 3 negative 1s, so it ends with a minus 3. So when writing that out, we'll put (2x squared) minus 1x minus 3. When you have a minus of 1x, you don't need to put the 1 in front of it. I can just put minus x, and that means the same thing. Okay, so right now solve this, but using the box method for b. So set up your box. And in this case, you can put 2x and negative 3 on the top, x and positive 1 on the side. Multiply those together. Remember to combine your like terms, which will be the diagonals here. And then see if you get the same answer that we got for B. Do the same thing for C, but what you're doing is the double distribution. And then combining your like terms as your last step for this. Okay, so now coming back, here is what your box should have looked like. And once we do combine those like terms, negative 3x times plus 2x is negative 1x. So we still get the same thing of 2x squared minus x minus 3. Remember that when you're multiplying polynomials, like this x is to the power of 1, this 2x is to the power of 1, you add the exponents together. Okay, let's look at this next one. Again, combine the like terms. 2x and negative 3x is negative 1x. So 2x squared minus 1x minus 3. So we still got the same answer there. So for D, in your own words, write something to the effect of all 3 methods, Algebra tiles, box method, and distributive property, get you the same answer. Okay, you guys are going to work on finishing the rest of this on your own. I'm going to show you how I set them up, but then you're going to be solving them on your own. Once you finish solving them, then you can go to the document in the Schoology page, which is a form saying which question you had gotten up to and finished. So here is how we set up question number 15. Question 16 is a slightly modified box. Because this has a trinomial times a binomial, there are 3 along the top and 2 along the side. One thing to note, when I'm multiplying these, x to the power of 1 times x squared, I add those exponents together. So x to the power of 1 times x to the power of 2 is x to the power of 3. Same thing here, again, another modified because it's 3 by 3. And again, remember that you're adding the exponents together. So 2x squared times x squared is 2x to the power of 4. And when we have just regular x to the power of 1 times x squared, x to the power of 3. And remember that what you're looking to do at the end is to combine the like terms. And if you did it correctly, your like terms should be these ones that are diagonal to each other. So in this case, we're going to have 3 sets of like terms that you can simplify before you then write your final answer. So your final answer should have 1, 2, 3, 4, 5 terms in it. So your final answer should have 5 terms, and the leading coefficient is 2x to the power of 4. Okay, for 18, you're just doing 1 term times 3 terms, a monomial times a trinomial. So we can just do distribution. And then for questions 19, 20, and 21, you can solve these with box methods. Here are 2 examples. And remember that for 20, when I have x plus 4 to the power of 2, that means x plus 4 times itself, x plus 4. So that's why when I set it up, x plus 4 is on the top and x plus 4 is on the side. As you're working on these, you can use polypad for the algebra tiles or do distributive property if you prefer that. But for these, I had set them up using the box method. Again, once you finish this, go to the Schoology page and complete that Google form, which says, which question did you get up to?